Now, we're going to be solving some questions on work, energy, and power. Mostly, we're going to be looking at some WIRE questions, WIRE tutorials on work, energy, and power. And the first question here is the engine of a train produces a force of 3000 Newton when moving at 30 meters per second. Calculate the power of the engine. This is WIRE 2006. Let's solve the question. Now, look at this. We have given. The first thing is the engine of a train produces a force of 3000 Newton. So we have our force is equal to 3000 Newton. Now, the next thing is when moving at 30 meters per second. Now, 30 meters per second speaks of speed or velocity. So we take it as speed, which is 30 meters per second. The question now is calculate the power of the engine. We're asked to calculate the power of the engine. Now, power is question mark. Now, power is given as work done over time taken. Because power is the rate of work done. So the formula is work done over time taken. Work done over time taken. Now, if you look at the parameters here, the parameters were given. We don't have work. We don't have work done. And we don't have time. So we don't have work done, we don't have time. So it seems as if the formula is useless, but no, it is not. We can still solve this question. Now, look at this. We know that work work done is equal to force times distance. Force times distance. Now we can equally say that power is now going to be force times distance. We use S for distance over time. Now, if you remember clearly, if you remember acceleration, when we're talking about linear acceleration, velocity, and speed, you will discover that speed is given as distance over time, which is the same thing as S over T. Therefore, we can say that S over T, this S over T stands for speed. So we can equally say that therefore power, which is P, is equal to force times speed. Power therefore is equal to, the force here is 3000 Newton times our speed is given as 30 meters per second. Now power now is going to be equal to, if you multiply this 30,000 3,000 times 30, 3,000 times 30 times 30, we're going to be having 90,000. 90,000. Now 90,000 power is measured in watt. 90,000 watts, or 9.0 times 10 raised to the power. We have 1, 2, 3, 4 times power 4 as W. This is our answer. Now let's look at another question. Now this is also another question. The question says an engine raises 100 kg of water through a height of 60 meters in 20 seconds. What is the power of the engine? take G as 10 meters per second squared. WAEC 1989. Now, let's bring out what we are given in the question. The first thing is an engine raises the mass is equal to 100 kilograms of water through a height. So we have H as height. H is the same thing as, let's represent this using M, which is equal to 100. We have our H, which is equal to 60 meters. Then time, which is 20, that's time T, which is 20 seconds. Now, what is the power of the engine? So I asked to calculate power. Don't forget we still have G. G is 10 meters per second squared. So power is question mark. Now, those are what we said. We know that power is given as power is equal to work done over time taken. This is also the same thing as, okay, let's have it here. Power is the same thing as work done. We don't have work done given. Work done is also the same thing as force times distance over T. Now, we also have that force is also the same thing as mass times acceleration. So what we have here is G. So we don't have a linear acceleration. We only have acceleration due to gravitational effect. That's acceleration due to gravitational force. So we're going to have F. We're going to present it as F. F becomes mg because force is mass times acceleration. So acceleration here is due to gravity, not a linear one. So we have mg times s over t. That's for the time. Now, if you observe here, we have mass for this m. G, we have g. If you observe here, s here is going to be taken as our height. That's our distance covered, since it's based on gravity. It's a height. So we're going to take it as our distance, and then time is 20 seconds. So we have power, which is equal to 100 times G. G is 10 times S. What's our S? 20. Sorry, our S is 60, that's in meters. 60 meters over our time. Time is 20 seconds. So we're now going to be having, you can cancel this, This 2 goes into 2, 1. Into 6 is 3. So we can have 100 times 10 times 3. So we're going to have 100 times 10 times 3. So we have 3,000. We have 3,000 watts.